Now, what's the difference between momentum and moment? Let's look at these two things based on these three different angles. The first one is the formula, the second one is the principle, and what are the related concepts that develops around these two things. Now, let's look at the formula for momentum. Momentum goes by the formula mass times velocity. Now, the unit of mass is kg and the unit for velocity is meters per second. Now, we know that velocity is a vector quantity, therefore the sign matters. So there's a positive and negative sign just to indicate the changes in direction. And in terms of moment is also known as what we call the turning force. So it has to rotate and revolve around a center or a pivot in this case, and you can see that the formula develops around this. So it goes by force times perpendicular distance from pivot. I want you to know that the unit for force is what we call Newton, and the perpendicular distance from pivot is meters. When it comes to the principle for momentum, right? So we call it the principle of conservation of momentum, which kind of means in a closed system, the total momentum before is equal to the total momentum after. So you can kind of just map it out this way: mu, mass times velocity, and this is initial velocity, equals to mass times final velocity. This is of course just a simple depiction of the conservation concepts, but if you wanted to revolve around the context of a topic, right? So there's elastic and inelastic collision. So what happens is that elastic collision is when two objects collide into each other and then they bounce off, right? They're not sticking together. So there are two objects involved, so you do m1 u1 plus the momentum of the second object m2 u2 equals to m1 v1 plus m2 v2, which is to match with the principle of conservation. Now, when it comes to inelastic, it's when these two objects collide and stick together. We do m1 u1 plus m2 u2, and I'm sure that they share the same velocity, so you can kind of just factorize it out. But yes, they do go by v times m1 plus m2. So this is pretty much how momentum works. For moment, principle of moment states that if the system is in equilibrium, total clockwise moment is equal to the total anti-clockwise moment. You can just imagine this way: clockwise moment equals to anti-clockwise moment. So there are a few things that you need to determine when it comes to moment. First, it has to do with the perpendicular distance from pivot. If this is the pivot, this is where the force is acting on the wooden plank or anything along the system. You can see that this will be the perpendicular distance from pivot. Now, what about clockwise and anti-clockwise? For this particular example that I'm giving, the force revolves around a center in this particular direction, and this is a clockwise direction. Now, just to give you a little perspective for anti-clockwise, this would be an anti-clockwise moment. So that's the difference between momentum and moment.